Hi, this is Greg. Welcome back to my channel. I know it's been a little over 2 weeks since I published my part 4 of this grinder series, and I apologize for that. I have been out here working as time permits in the evenings, an hour here, an hour there, and I've accumulated about 10 or 12 hours of machining video, which I won't bore you with. Got busy at real work. I have a real job still. I mentioned in my opening Garage Odyssey video that I'd be retiring soon, and that soon is 2 weeks from now, which is pretty exciting. But as my ultimate date comes up, all the customers have been putting things off for so long, all of a sudden have 17 things for me to do. So I've been really busy at real work. Haven't spent so much time out here in the garage. Let me get you over here to the grinder, show you what I've got now. I figured I'd show you the finished product here first, and then go into some details. So here's what I've got. As you can see, I built all these pieces here in my first part 3, part 4 videos. And for this video, I built the Platen frame with the Platen wheels on here and this tension handle. Now this tension handle is quite different from Phil's design. His gas strut here is actually permanently affixed, and then he uses this lever to relieve the tension on the wheel when he changes belts. In mine, I've changed it quite a bit. I'm going to have to put the camera down to show you its operation. But and then another neat feature I've done on the Platen frame is I've cut these notches here for various angles that you might typically want to use. So obviously there's my 90. I've got it currently in the 45 position just to show you here. But it makes a quick change, you know, to quite accurate angles on these guys. Very easy, which I like. Works well. And then my lever, rather than machining it out of pieces like Phil did, I just took a piece of, I believe that's quarter inch steel and bent it. I just put it in my vise and hit it hard with my hammer, heat it up and hit it hard to make this curvy shape, which I like. I doubled up the thickness here. I welded an extra piece in there to double it up for extra strength and extra bulk. For this, another shoulder bolt goes through there to hold it in. And then I'm going to put the camera down here so I can show you the basic adjustment process. Now, this is really shaky. I can't be doing too much with this right now because I don't want it falling down. It's all too easy to do. But basically you would release this lever, which lets this main arm slide in and out, and then you release this, and that lets that pivot, and this, you release the pressure on the belt. All right, so you release the pressure on the belt first, do your adjustments, blah, 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 blah. Tighten things up again, and then you're ready to go, right? Oh, I guess I need to pick this up again to show you the back side of this. That there is the tracking arm adjustment, and I made a nice little fancy knob for that out of brass. And I made another nice little knob here out of brass. Very simple lathe operations. So let's see. I think I can show you this thing running at this 45-degree setting. And then I'll separately adjust off camera for the other settings. I don't want to do it on camera because it just takes too long when I'm worried about the thing falling off. Okay, I need 2 hands and I need to do it by hand. So let me tighten these guys back up in the 45 position. Apply some tension again. Again, I've got various tension settings here that are according to what angle you have this at, because the belt gets longer here and shorter here as you tilt it, right? So the belt changes dimensions basically. Okay, I think we're ready to go. So here's the remote control guy that I built in part 2 of this series. So I'll turn on the VFD, and then I'll put it in the forward direction, and then I'll give it some speed. And there it is, ta-da! Now I'm not going to go terribly fast with this because, again, this is kind of shaky, but it tracks very nicely. The tracking wheel is very responsive. I've got it here so it's just tracking on the very outside of the 2-inch wheels, which is perfect. You can go around the corner if you're putting the part like that on there. It's quiet, it's stable, it's smooth. So okay, let me show you the other positions. So here we have it at its most laid out 15-degree position. Or if you look at it the other way, if you flip your part over on the table, it'd be 75 degrees on the other side. Take your pick. I don't have a Platen installed here yet, or the table, but you get the idea. They're coming soon. Now here's the 30-degree position, which of course if you flip the part over would be 60 degrees. There's another one in between there, the 22.5 I'm not showing right here. It's half of 45 of course, which might be useful sometime. And here is the ever popular 45-degree position. And as I note there, the lever keeps moving down so that because the tracking wheel keeps moving up, so you get more pressure on the wheel that way. And here's the 90-degree position, which of course is the most used. And the Platen frame there is, square against the main frame, so it makes it a perfect 90 degrees every time. So now I want to show the parts I'm going to be making in this video, starting with the Platen frame. It's the main part of this video. A few extra features from Phil's made it a little fancier. And the Platen wheels I bought off eBay just as a kit for this grinder, but I still need to, the axles are going to be half-inch bolts. I need to make some spacers for them to fit on properly. I'm going to be making this tensioner arm. In my case, it's going to apply the pressure to that gas strut, whereas in Phil's it releases tension through this slot, pulling the strut down. I'm not going to be making the Platen or the Platen bracket. They'll be the subject of another video. They're very simple anyway. So I'm going to start on the lathe making these very simple Platen wheel spacers, just out of 1-inch material I had lying around. This gets drilled out. There's 2 of them, so they get parted off here at the proper length with the DRO. Face down, making the second one here, and reaming out to 1/2 inch for the bolt. Okay, over on the other bench where the grinder is going to live, I've got the motor attached to the main plate and the dovetail and the tracking wheel, and I had this piece in there as well so that I could put over an actual 2x72 belt to see how things are going to work out. And they're working out well. I mocked up this piece of wood before I commit this to metal. I mocked it up in wood with these guys 12 inches apart, which is a little closer than Phil's. And then I was just playing with it, pivoting it on here to make sure I had the proper clearances with the main plate and so on. And it was just, it's kind of hard to hold everything all at once. So I think my next thing I need to do is to actually commit to drilling this, this pivot point here that this main Platen plate is going to pivot on. Phil uses a custom-made pivot bolt here, kind of fancy. I'm just going to use a grade 8 bolt. I think it's actually better and stronger. All the way through. I'm going to drill this through there and tap the end of it so the threads can tap in there. So now I've got my attachment arm mounted in the vise on its side. You may recall that I drilled 3 pair of holes to attach the bracket here rather than 2 sets in Phil's design. So I need to be very precise about my hole going through here as it goes between the rear set and the middle set. There's plenty of room, I just have to be careful with it. So I'm going to do some edge finding here, or some center finding of these holes that are already there for the attachment bolts, and hit them in my DRO, and then pick the halfway point between them. That's where I'll drill my 1/2 inch hole. And that looks perfect. So here's my mock-up, as I mentioned earlier, to test the dimensions. Looks like I'm doing good. I put the dovetail tracking arm in here and just clamped it in a reasonably high position. It can go up and down from there, a few inches up and a few inches down to adjust the tension automatically. But I have the wheel on the motor with the proper amount of space. It lines up with this. I put these 2 Platen wheels on this cardboard mock-up on the proper hinge point on the attachment arm here. Of course, the table will attach out to this thing out here. That's a to-do. But with that tracking wheel in that position, this is just about the right amount of tension right there for this thing to be up square. Of course, there's a bit of flex, it's wood, but that's just about it. So I spent a little more time this morning prototyping this in wood. It's a very important decision here to get all the geometry just right. Of course, if I had a proper Fusion 360 diagram of this 2x72, I could do this with the Fusion 360 and save myself some time cutting out of wood, but I still kind of like the hands-on of really looking at it and seeing if everything's going to work out. So there's my original piece, and there's my original hole. I had 1, 2, 3, 4, 5 different experiments here just to see how the geometry changes. And there's always a trade-off, as in most things in life. As you lower this hole down, you get more grinding area, which is nice, but then the effect of the tilt is much more pronounced on the wheels. Like this wheel gets a little bit shorter, and this wheel gets much shorter, a little longer, much shorter. So you have to have more tension adjust, or much more adjustability here. Ideally, this would be in the center. Then both wheels would move, at the same, one get longer, one get shorter at the same rate, but then you lose quite a lot of grinding area. The other advantage of moving it further up this way, is you get more ground clearance, but I've already figured out when this thing tilts horizontally, I need enough ground clearance to clear the motor, obviously, and that's plenty, means I've got plenty here still. My mount will be higher than this. So we're good there. So I think it's a good compromise. And as I extend this out, yes, this wheel gets a little longer, this wheel gets a lot shorter, so the adjustment arm here has to move out to compensate. I mean, there'd be some compensation in the tension arm here too, but it might take up an inch or two, not as much as I need here. So that's the reason for this adjustment arm moves out. When it's done, there'll be a lever clamp here per Phil's design that holds that in place. And so I can get all the way out to flat across here with this adjustability. This slot here, I just freehanded this on here. There'll be another lever clamp in here that bolts on to keep this thing from turning. And so I've just sort of laid out where the top and bottom need to be. Okay, I used my DRO to find the X and Y, zeroed them out, moved in 7/8 of an inch. This is a 2-inch wheel, so inch radius. So that'll give me an 1/8 of an inch overhang, top and front. Clearance is clearance. That's just in case the belt rides off the end of the wheel here while you're tracking it. In normal use, it's going to sit in the center of this wheel, obviously. And the wheel sits a bit off the plate anyway, so this is just overkill to allow clearance over here, but it looks nice anyway. So I'm going to have an 1/8 of an inch hanging over the front and the back, and I just put a transfer punch in, 1/2-inch transfer punch as a hub for the wheel, just to test it out that it all looks good, and yeah, it does. I wanted to do that before I committed to the drilling. So now I'm going to drill that out for a 1/2-13 tap. So now I've just laid my piece of wood prototype on top of my bolt holes, and just with a Sharpie marked where the center of this is. There's nothing precise about this. It can move within an inch sort of area of this spot, and the behavior of the platen changes a little bit, but not drastically. So there's nothing precise about this. I'm just going to drill my hole there with the Sharpie mark and ream it out to 1/2 inch for the hardened bolt that's going to form the pivot here. So as I mentioned when I was making the tracking wheel, each of these wheels has a retaining C-clip inside that if I put one of my regular size washers in there, it will ride on the C-clip and bind, which isn't good. So I need to reduce some washers to just inside that C-clip diameter. So the way I'm going to do that, I've just mounted 4 washers on here. I need one for each of the 3 wheels, and I put the 4th one on there just to give me some clearance. I don't want to hurt this piece. These are the 2 pieces I made for my spacers for these Platen wheels. So I put them on here on a 1/2-inch bolt, 4 washers. I'm going to put them in the lathe and then take these washers down to just over the size of this outer facet of the bolt head, and that'll be the right size to fit inside that C-clip. Okay. So as you can see, I now have it assembled here on my bench in this sort of Rube Goldberg kind of setup. Again, I don't have my proper tensioner on here yet, but I've got a belt on here with a new piece of metal all bolted on, the proper spacers and everything working out well. I cut off the bolts on the end here so I can rotate it without interference. And then I just moved it around by hand just to adjust the tracking wheel and found I could get it tracking center. And I thought, well, just for the heck of it, let's go really, really slow for a first test with the actual motor. It should be forward. There we go. Actual test. And it seems to be doing really well. It's tracking on here nicely. I say I did do a little adjustment on here by hand. So it's alive. Okay, so I've had this thought. I pointed out before, this is a perfect 90 now. If I bring that up there, that's a perfect 90, and the tension is good there. And I'm also going to make it a 45 cut, which I've done already. I made this a perfect 45, but I think it'd be better to actually notch this away so that this top surface also comes down flat on here. It'd be a positive, 45. And then I can do the same for a 30. These are just rough lines on here just to get an idea. But for a 30 degree, and of course this will push in a little bit, and for a 22.5, just common angles that you might want out here. Oh, I've also got a 15 up there too, don't I? That sort of lays it right out at 15. So I'm going to try this. I'm going to cut my 45 here first. I'm going to have to figure out a way to get my cutter in this way on the mill so I can get a square in there. May not be able to do it, but I'm going to give it a try. Okay, over on the bench I've got this die cammed up. I'm just going to cut my 45 first, and after I get it perfect, then I'll go on and move to the next one, iteratively, as I do a trial fit each time. So I've got my line here that's going to match up with the top of the main plate, approximately. I'm being on the safe side, moved it a bit that way. I'm going to make each of these notches 3/8 wide, and then this has to be a perfect 45, using this as the reference. So this will give me a 45. No, not a good one. Go this way. This will give me a good 45. Sure my head's in the way again. Scribe along there. So that's where I'm going to mill down to. So I've got another janky setup here in the mill. There's the line I want to cut across there. I'm going to reference onto here. It's not dialed in yet. This isn't tightened in yet. But basically I made myself a couple of rudimentary extension jaws with some heavy steel here. And I've got my plate down in the channel of my mill. I arranged my vise forward and back. I had just enough adjustability to make sure that that opening here was down in the channel, which lets me get a little lower, which gives me a little more clamping force in here. And then I've got a little space of the same material back here, just clamped onto the bar just to keep the jaws square as it tightens up. So it's kind of janky, but I think it's going to work. I mean, it seems, if I tighten it up, it seems good and strong. I'll do light milling passes, obviously. But that's what we got. Oh, and I'm going to use this C-clamp here to further clamp these two pieces of extension jaw together around the piece to keep it nice and tight in there. All right, so here we go. Okay, the 45 is done. Now I just show you how I dial in. The next one's going to be 30 degrees. So I don't really care what angle this sits at. Obviously, it's not quite square. As long as I zero this here, and it'll read accurately what that angle is there. So 30.2. So I die cam that up. I want to mark where my stop is going to be, which is right there. Over at the grinder, I got a mark there to give me some guidance. I can get a much more precise 30 degrees here using this as a reference surface again. Actually mill too, so I'm going to go down to that corner there and take that off just like that. Okay, back onto the mill. Okay, got it clamped back in the mill here again, the same sort of janky setup. And I've got it running true across here. I actually used a tooth of the mill to very lightly score just above my actual line there, just to make sure it was parallel. So it looks like it is, so I'm going to now mill down to that second line. Okay, there's the second one done, the 30-degree one done, and it's a nice tight fit. Fits in there just perfectly, hardly any daylight, any. So the next one I want is 22.5. Now let's get this knocked down to there. 22.5, right there. So again, what's most important to me is to get this notch in the right spot without going too far. Right there. And now with everything reassembled, I used some Prussian blue on the tip of the plunger to mark the best position of the lever arm for good tension in each of the positions of the grinder. And then I center punched the center of that Prussian blue, and I repeated this for each of the positions until I had the complete set like this. Then I, of course, center found and drilled them out to a consistent depth for the plunger. And here's that final result. Made a brass handle for the tension lever. Don't have my compound installed here, so I'm using my right hand just to move it out, put a little bit of a taper on it. And then I went down and every 1/4 inch put a consistent groove depth just along its length to make it look pretty. And then I drilled and tapped it to, I believe it was an 8mm threaded rod I'm using here to attach this to the tension lever. Of course, then I did the corresponding thread and tap of the tension lever itself and rounded over that end as well. I also made a simple brass knob for the tracking adjustment screw. There I'm drilling it and tapping it for 12mm to a shallow depth. And I mounted a 12mm threaded rod with retaining compound and put it in the mill in one of those 6-sided hex collets so I could mill out 6 little knuckles like this to make it look pretty. So as I was nearing the end of this phase of the project, I had the great idea to cut out these triangle features in the Platen frame for visual appeal. It turned out to be a lot more work than I'd anticipated. Doing the 90-degree parts were easy enough, but getting the reach to those diagonals was hard with my mill dimensions. I had to do several different setups. I started by cutting the holes out roughly with drill. And here I am just finishing the one edge of the Platen frame I hadn't done yet on the very bottom surface to that angle that's the same as the triangle inside. There I am doing the triangle. Then there was about 2 more setups to get the rest of this thing done, so it took quite a while, longer than I thought again. Of course, chamfering that edge as well. And I cut out a lot of footage here because it's just pretty boring stuff, but I'm happy now that it's done. I mentioned in an earlier video in this series that I had a little excess play in the dovetail of this tensioner arm I wasn't happy with. I figured a little powder coat would add some thickness to reduce some of that slop, and it really did help quite a bit. Here it is baking in the oven. But I found I also needed to put a little shim in behind it. An 1/8 thou shim was just perfect in behind the dovetail to take out that play. And here's just me trimming that shim to width in the mill. So we finally come to the end of part 5, and I apologize again for the length of this video. We'll wrap up by showing the grinder again, 4 of its 5 positions in action here, and then talk about what's next, which is going to be building these 2 brackets that attach the grinder to its stand and allow it to pivot horizontal and vertical. And then, of course, the stand itself, which is going to be a pretty heavy-duty 2x2 square tubing affair that's going to be TIG welded up. So it's going to be a lot of TIG welding and some cutting, but very little machining in the next video. I hope you join me, and thanks again for watching. Bye for now.